Good morning, everybody, and welcome to the DC preliminary of FameLab Astrobiology. I'm Sean Domingo Goldman. I'm going to be your host for this morning. I'll be introducing our contestants, but before we get to that, I'm going to introduce our judges who have so graciously volunteered to provide their services to us today. I'm going to start on your right with David Grinspoon. Dr. Grinspoon is curator of astrobiology at the Denver Museum of Nature and Science and is an adjunct professor of astrophysical and planetary science at the University of Colorado. A frequent advisor to NASA, he is lead scientist for astrobiology on an instrument that is now on its way to Mars on the Curiosity rover. One of his books, Venus Revealed, was a Los Angeles Times Book Prize finalist, while another, Lonely Planets, The Natural Philosophy of Alien Life, was a Penn Literary Award for research nonfiction. His popular writing has appeared in Slate, Scientific American, Natural History, Astronomy, the Boston Globe, the LA Times, and the New York Times. He was awarded the 2006 Carl Sagan Medal for Public Communication of Planetary Science by the American Astronomical Society. Please help me in thanking David for joining us today. Next to David, we have Linda Billings. Dr. Billings is a research professor at the George Washington University School of Media and Public Affairs in Washington, D.C. She does communications research for NASA's astrobiology program in the Science Mission Directorate. She has also advised NASA's lead scientist for Mars exploration and NASA's planetary protection officer on communications. Her research has focused on the rhetoric of science and space exploration and the social construction of scientific authority. She earned her PhD in mass communication from the Indiana University School of Journalism, her MA in international transactions from George Mason University, and her BA in social sciences from SUNY Binghamton. Please join me in welcoming Linda to the FameLab stage. Thanks, Linda. And next to her is Bill Margol. Bill Margol is a graduate of Syracuse University's S.I. Newhouse School of Public Communications. He has worked for the last 23 years in many positions in the television industry. Covering the ground of writer, producer, editor, developer, and executive, Bill has worked at the Sci-Fi Channel, TNT, the Travel Channel, where he launched the groundbreaking series Anthony Bourdain, No Reservations, and Discovery Studios. In 2008, Bill joined National Geographic Television as Director of Development, and in 2011 took on the role of Vice President, heading up all development for National Geographic Television. Bill has a love of science and adventure, and in spite of that, the fact that he would most certainly lose his lunch in his helmet, dreams of one day being an astronaut. Please join me in welcoming Bill to the FameLab stage. And finally, next to me is Nikki Lowry. Nikki is Director of Film Marketing and Outreach for National Geographic Cinema Ventures. As such, she markets their giant screen and digital films to museums and science centers, as well as manages the education outreach for these films, with particular emphasis on STEM education. Nikki's experience spans education and entertainment marketing. She has served as film commissioner in Park City, Utah, as well as director of marketing for the Sundance Institute, the Sundance Film Festival, and the Miami International Film Festival. She has taught college-level English language and literature. Figures I get that part of it wrong, right? She has taught college-level English language and literature and English as a second language in both Thailand and Lebanon. She has been the senior marketing manager for the National Geographic Explorer Classroom magazine, which brings science content to 2 million students in grades K through 12. Please join me in welcoming Nikki to the stage.
If there is indeed life on Mars, or anywhere else in the solar system for that matter, the first thing we will have to determine is, well, how does it make its living? And what can you say about ecology on Mars anyways? As it turns out, more than you would think. What we do know is this. On Earth, there are several locations that are surprisingly close approximations to the surface conditions on Mars. One that is particularly near and dear to my heart is the Blood Falls Formation off of Taylor Glacier in Antarctica. And when this event is over, you all really ought to go home and look this place up online because it is amazingly photogenic. It's this occasional discharge out of a pocket of seawater that's been isolated underneath a glacier, completely cut off from the rest of the world for the last 3 to 5 million years. And the water that emerges is so enriched in iron that as soon as it hits the oxygen in the air, it turns bright crimson red, hence the name blood falls. And all that iron, as it turns out, is the result of a thriving bacterial community. The reason these microbes have been able to survive in the cold, dark, and nutrient-poor environment underneath Taylor Glacier is because they have formed extremely close relationships with each other. One microbe's waste quickly becomes another's food, and the scarce nutrients are cycled through the entire ecosystem with incredibly high efficiency. The take-home message from the example of Taylor Glacier is the reason this ecosystem is possible is because it is an ecosystem. It's not just one organism, it's a whole community of microbes and other creatures working together to make a living. Now, this has exciting implications for Mars. We now know that it is likely that early in its history, Mars once had a vast ocean covering its entire northern hemisphere. As the planet cooled, the ice caps expanded and the oceans receded. And it is not inconceivable that a pocket of water may have been trapped within the ice cap, as happened at Taylor Glacier in Antarctica. And if that is in fact the case, then it is not at all unimaginable that there may still be hardy Martian ecosystems residing within. Thank you.
Thanks so much. I liked your topic. One suggestion I would have is that you might want to tell us what you're going to tell us about right up at the beginning. You grabbed my attention, but it's sometimes helpful to keep everybody on focus. And I thought you injected a good level of engagement with your subject, and I was getting more and more interested. And I really liked your description of early Mars and how the planet cooled, and this is where Mars may be today. That was very nice. Thanks.
Yeah, I agree. You clearly are enthusiastic about your topic, and that shows well. And yeah, I would just echo what Linda said. Sometimes it's good to tell them what you're going to tell them it, and then tell them what you told them. And so a little bit more structure so we could see the path that you're on. But having said that, it was an interesting path, and you pulled us along nicely.
The other thing that you did well was connect the dots. You know, in storytelling, we often have to say, okay, it's sort of, yeah, it's tell them what you tell them, all of that, but also take someone on a journey. And what you did is you said, okay, here's Mars. Now, here's the situation in Antarctica, and then you brought it back to Mars. And I think it was a good way of connecting all the dots through the presentation.
I forgot to take notes because I was listening so rapidly. Yeah. Your enthusiasm, great. Clearly, you're very interested in your topic, and that's always good, and it showed. And again, I like the logical progression and love the bit about the synergy of the microbes. That was great.
Thank you. Oh, that was nice. The possibility of life on Mars has been the subject of speculation for literally centuries. And excitingly enough, it is likely that within the next 15 to 20 years, we will finally be able to resolve this age-old question. However, I've occasionally been asked, nonetheless, why is finding life on Mars important? After all, it's looking exceedingly likely that the Martians won't be anything more than primitive single-celled organisms. Certainly no one we could talk to or exchange ideas with. Although, on the other hand, they probably won't invade either, so there's that. However, even the discovery of primitive microbes, as unremarkable as it may seem, has the potential to rewrite much of what we know about the universe. To start off, one intriguing possibility is that life on Mars may have been seeded by microbes from Earth hitching a ride on meteorites, or for that matter, vice versa. Now, arguably, this would be a less exciting discovery, if this in fact turns out to be the case, since the Martians wouldn't be so much as aliens as distant, long-lost cousins to us. However, this could still tell us much about life in the solar system. And furthermore, a Martian branch of the tree of life may have been isolated from its terrestrial relatives for millions, perhaps billions of years, and could give us great insight into our own evolutionary history. A more exciting prospect, at least in my personal opinion, is that of a totally native Martian life. Even if it's extraordinarily primitive, this discovery has the potential to be Earth-shattering, or, well, Mars-shattering, as the case may be. A fundamental question in astrobiology today is, what exactly are the requirements for life to come into being? Is it a rare, almost miraculous event? Or is life the rule rather than the exception, springing into existence wherever there is water, energy, sufficient nutrients? Energy in this case being represented by an Alka-Seltzer tablet, and life being represented by foam dinosaurs from the dollar store. If we were to discover life on Mars that had originated independently, then this would mean that this had occurred twice within the same solar system. And that is a strong argument for the latter case, and may mean that our galaxy has just gotten a whole lot more crowded. Thank you.
So do you think we will ever live on Mars?
Well, for one thing, if we're willing to spend the money for it, probably. Beyond that, I don't know if we run into anything that would be a showstopper, although if there is indeed life on Mars that's native to Mars, then there are a lot of ethical concerns that pop up. So really, I don't see anything in the immediate future that would prevent it, but I don't know if we have enough information to really be able to make that decision right now.
If there is life on Mars in any form, why haven't we found it yet, and what are we doing wrong?
This has actually been a topic of debate fairly recently. As was mentioned earlier, the Viking biological experiments were sent in the late 1970s, and they came back pretty inconclusive. Some of them said were positive of life, others were negative, and some didn't really make any sense at all. One suggestion has been that the Martian soil has certain compounds in it which are very chemically reactive, and that may have thrown off our readings. The interesting thing about these is that many of them are salts, which we know from bacteria that live in very dry environments on Earth, like the Atacama Desert, which in some cases hasn't received rainfall in recorded history. The microbes there use these same types of salts to basically, both as an antifreeze, but also it gives them the ability to basically absorb water vapor directly from the atmosphere, which in a dry, cold environment like, say, Mars, that would be very handy. So that is one possibility.
You said that you think within, I think it was maybe 20
years.
20 years we'd know the answer, and that if the answer is yes, there's life on Mars, then that means the universe is crowded. So what would be a mission and a result of that mission that would make us conclude that there isn't life on Mars? And if we reach that conclusion, does that mean that the universe is very uncrowded?
Well, that gets tricky, because if you remember, some of you might remember from any philosophy classes you may have taken long ago, you can't prove a negative. However, if basically none of our tests, and we've sent a lot of them at this point, absolutely nothing shows up, then it's probably pretty likely that there isn't life there, which may indicate that the formation of life coming into being is a much rarer, much more unusual event, that it really is something a little bit special.
Good job. Thanks.
Oh, thank you.
Thank you very much.